हरि करना।
So why learn probability? So this is our population and a population, and we use a probability using the probabilistic or probability sampling. We take a sample from it, and then in return we give statistics back to the population. So you use probability to take a sample from the population, then you use statistics and do the inferences from the population, and you give statistical inferences to the population, and you estimate the statistics of the population. That's what a probability gives. That's what the probability does to statistics. So nothing in life is certain. So in everything we do, we gauge the chances of successful outcomes, from business to medicine to the weather. A probability provides a quantitative description of the chances or likelihoods associated with various outcomes, and it provides a bridge between descriptive and inferential statistics. Very important, very important. That's what I visualized here. That's what you see here, an animation which is a bridge. The probability is a bridge between descriptive statistics and inferential statistics. So probabilistic versus statistical reasoning. So probabilistic and statistical reasoning are closely related concepts, but they have some important differences. The probabilistic reasoning refers to the use of probability theory to make predictions or draw conclusions about the likelihood of events or outcomes. So this can involve calculating probabilities based on known data or using subjective estimates of probabilities based on past experience or intuition. Probabilistic reasoning is often used in decision making contexts where uncertainty is present, and there is a need to weigh the risks and benefits of different options. So this is probabilistic reasoning. As I know the population and predict the sample, so suppose I know exactly the proportions of car makes in California, then I can find the probability that the first car I see in the street is a Ford. This is a probabilistic reasoning, as I know the population and predict the sample. Statistical reasoning. Statistical reasoning, on the other hand, refers to the use of statistical methods and techniques to analyze and interpret data, and to draw conclusions about the characteristics of a population based on a sample of data. So this can involve calculating summary statistics, performing hypothesis tests, or building models to explain the relationships between variables. So statistical reasoning is often used in scientific research or business analysis where data driven insights are needed to guide decision making. So now, suppose that I do not know the proportions of car makes in California but would like to estimate them. I observe a random sample of cars in the streets, and then I have an estimate of the proportions of the population. This is statistical reasoning. So while probabilistic reasoning and statistical reasoning are distinct concepts, they are often used together in practice. For example, probabilistic reasoning can be used to estimate the probability of certain events or outcomes. And the statistical reasoning can be used to test hypotheses or build models based on the observed data. So, by combining these approaches, researchers and practitioners can gain a more comprehensive understanding of complex phenomena and make more informed decisions.